So, hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 165 and we continue with our classes and with our constructors. Here in default constructors we already talked about the first syntax here, the second syntax, and now we should talk about the other variations a little bit too. And we will not talk too much about it because they are not too often used, but we have still to talk so that we know that something like that exists. And let's get started. So what we see here is the delayed word here, and this one is not often used. So you will not see this one very often because this deleting a default constructor in this way makes not really sense. What I mean with that is, let me show you this fast in an example. So you can see here is my class house, and here this is my class house. I have simplified it again, so we have only a variable name here and a house number, and that's it. And here a default constructor, I made it this way, and this default constructor we can explicitly say it. That means explicitly means that the programmer is saying this default constructor should be deleted. That means explicitly, and implicitly deleted means that the compiler will delete this constructor, this default constructor implicitly. And the normal case is this here is done by the compiler. So in cases where, for example, we provide a constructor, a non-default constructor. For example, here we have a default constructor, and let's copy this fast. Let's copy this one and let's provide a non-default constructor, which is just, I can create here any type in, and let's say here test param. It's just for demonstration purposes, and you can see here now I have here created another constructor, but this one is not a default constructor because I have not provided here any default value. If I would provide here any default value, it would be also a default constructor, but in this case it is not a default constructor. And when we do something like this one, we still can define here this default constructor, but when I delete this constructor, let's say cut this one out, then the compiler will set the initial default constructor, which is normally creating when it's not finding a default constructor, to delete. So this kind of stuff here, what you see here, this one is doing the constructor normally. When you provide, in my case here, I provided here a constructor, a non-default constructor, which means now I'm only allowed to create, for example, a variable which is using exactly this constructor. It must use this constructor. It is not a non-default constructor. And when I hover my mouse now over this constructor and we read it, it says here non-default constructor is this for class house big house, so it exists not. And it is most time, in this case it is just not existent, but it will be implicitly deleted as well, normally. So let's continue with this one. So we have a non-default constructor. When I provide a default constructor, then I can say explicitly this delete. This means that what the programmer do, and this one is normally, you should not do this because, like I said, that is the job of the compiler behind the scene. Only in special cases where you will do this, normally you don't care. And here it says now is deleted. It's a deleted function. And yes, to read a little bit more about this one here, you can see here in the section where it describes this delete a little bit more. It says here also the implicit declared or default constructor of the class T defined as yes, this is just the definition and so on, where the default constructor will be implicitly deleted and how the compiler is doing this kind of stuff. And you can read this one here and then you understand it even better than me. But in general, as a starter, don't worry about too much. This kind of stuff you are not doing normally. This is only in special cases. Normally, the compiler is using this one behind the scene much to set the default constructor, for example, as deleted, which means it should be not considered, it should be not called, and something like that. All right, with that said, I think you get this, and we are not really using this. And the reason why we are not using this delayed, there is another more, let's say, more reasonable reason why we are not using this. What is the reason? Because if we want not to use our default constructor, we are just using this one here, because this one here, when I provide a constructor which is not a default constructor, the implicit default constructor will be not called like here, because I have provided now a constructor and the implicit default constructor will never be called. So you can see this delayed makes here not really sense to set ourselves. We can avoid this. But like I said, there are special cases where you will use this, but as a starter, we don't care about these special cases. These are very not normal cases, let's say so. Or the compiler is using it. That's more the normal case, that the compiler will set behind the scene what is deleted or not for the constructor. And in our case, if this is provided, the default is not set, and so on. All right, I hope you get this, because we don't need it, because if we don't want to use a default constructor, we don't use delayed, we are just don't declare it here and declare a non-default constructor. But careful, don't make this mistake here that you say, hey, when I cut this one off, this one will construct a default constructor implicitly. We know this, right? Because when I save this here, you see now it's constructed, the default constructor is called. So don't make this mistake to avoid, but when you like I said, when you provide here a non-default constructor, the default constructor is avoided, and it means you have to use this constructor, which means you have to use and provide a value, which is, for example, 5 or 4. And then you can construct this variable if it's so declared. All right, with that said, let's construct here again our default constructor, because I need this in a moment. And yeah, the next step is what we have here. Go to the second one. Here is something else strange. We have here a default constructor, this part, and it says here default. And this one is used, for example, if you want explicitly call the default constructor. And for this cases, let's kick this one for a short amount out. In this cases, you should not use something like that, what I do here. For example, here I provide no body information, which means I do nothing with this one. And instead, the normal thing what you should do is then use this version here with default. And the reason for that is behind the scene, again, in a technical, when I say behind the scene, I mean all time in a technical way, which is which is implemented in a technical way, which we don't know right now, and as a starter we don't care. And there is the performance is better when you use this one, and the behavior is different because the compiler is the, let's say, optimized for this one rather than for this one what I have here. It can cause anyway, I don't know, problems. Normally it should not cause problems. It can cause problems if you want to use a default constructor and use it this way, because this one is also a default constructor. But here I would normally use now this body here, and this one here is not considering this body. And like I said, behind the scene in technical terms, it is a little bit different implemented than this one probably, and that's why they say you should use this one if you want to use a default constructor. All right, I think that's okay. It's not too difficult as well. So we just remember this one we use only if we provide here this body information. So we would write here anything, and this one we are just using when we do nothing. For example, here I saved this one, and you can see now I can use it with this one here. And I use explicitly this one, but the same like before, you could use also if you have something like this one here, no constructor at all, or if you have other constructors here, then you can say explicitly this one here. But in general, it is again for cases where you want and say use this one. So let's go here one step further. The next one is the same like this one, just outside. We learned this parameter here, what you see here is just an outside definition. We talked about this. It is just when you declare this here outside, you have to start with the class name, and then you have to specify where this constructor can be found. Again, the same, the class name. That's why we have here class name. And we write only outside now default. All right, I think these are not so important things, but it's important to know. And there are special cases where they will be used with in combinations with, like I said, in certain scenarios. But for us as a starter, we can use all this kind of definitions with normal, in a normal way. Let's say here no default constructor, implicitly created one, or you create here this big house, which this one you should really create explicitly here, like I said. This one, if you want, use it as a default. This is the only thing what you should prefer over the other one. The other one you should only prefer, like I said, when you use the body and something like that. Let's say if you want to use here this body and initialize value or print out something, then you should use this one here. Like I said, let's cut it here and say this kind of things here are very, very optional. You can make it other way around. There are scenarios where you should use that, and there are reasons, but for we are starter, we say we know it exists, but we don't care so much at start. We know we can solve this in other ways till we find these special cases where it becomes a little bit more complicated. All right, with that said, let's go here down and talk about a little bit this example so that I finish this site here. There are a little bit more talking about constructors. Of course, you should read this one here that was this delayed here. And of course, you can read the other ones too. Here, this default constructor, this, I don't know if we have talked about this one. Yes, you can try to read this one. This is the explanations here are aiming for this one when it counts. And I said you can try to understand this and find the special cases, but in general, we don't care. It's starter so much. Later, yes, but not right now. So, but what we are interested is to understand these examples at least, and we will skip some examples because they use here again this base classes, inherited classes, and so we don't make this one. But the other examples we will talk fast through, so when you watch these examples that you understand them. So let's start with this here. It says here it is a struct. A struct is the same like a class. The only difference is this access specifier we have here. By default, it's public. It's a declaration of a variable x, and here what we have here, it is just a constructor of the struct, and the parameter has a default value. What means that? This one, when it has a default value, and and all parameters have a default value, this means this is a default constructor. We learned this, and this is our initializer, and this default value will be initialized as x here. I hope this was not too difficult, and you understand this when you see something like that. The only thing what I should mention here is that you never should use a bad naming like this, but I talked about this much. This is just for demonstration purposes, but you can see x, yes, bad, super, sub, very nice naming. This is a naming where you can confuse everybody. All right, we skip this. And this second one, we see it, we skip this, we have not talked about this one. Let's see what we have here. And here we have our struct again. The struct is initially creating a variable, but of another struct, which is on top here. And then it says here, what it says here, it says here the default constructor is implicitly defined by the compiler, but this one calls this one. And I think I have not talked about this one. And I make fast an example. What does this mean? This line, I have not talked about this line, and that's perhaps important to understand. And for this purpose, I just copy these two structs here and demonstrate you what they mean with that, because there is a special meaning which you have to understand there. And I have not talked too much about this, and we want to understand these examples, right? So what is the special meaning about these two structs here? So here, and let's make here a real, let's define not an implicit constructor, let's define a real constructor, which means I make a C and then I, what was it? Let's do it with something or without something. Without something, let's make this way. And I need a body, that's why I want to make a constructor here and not the implicit constructor, because the implicit constructor would make this else well, but we have no body and I want now this body. That's why I create this default constructor with this body, and I want write here something. And what I want to write is I want access now this A, because I want to explain you something. Let me show you this fast. And let's say A point X, I get access of this X value here. And so now what happens here? Let me show you here. The important thing is here, when we read this, it says here the compiler, I mean the constructor here will call the A constructor, which means here on top. And why is this so? Or why I'm saying that? So first of all, to make it clear, let's create a struct C variable, right? A variable means we create an object. This time it is just a struct, careful struct, and classes are the same. Like I said earlier, the access specifier is different, which means we have here public access specifier, and the reason for that is I can access it here like this one, because it's public, I can access it. And the other one is also public, I can access it, which means I can create here a variable. Let's create a C variable. Let's call it this time with a real name. Explanation. Let's call this explanation. It's okay. And yeah. So at this point, when I create this variable explanation, what happens? What happens is this explanation jumps here in this struct. It tries to find a constructor. Yes, it tries to find, and it finds this constructor, which I have defined. It is the default constructor. Normally, a default constructor you don't have to write, but if you are providing a body like me, then you write this initial default constructor like this, because we are using now this body, and the body is trying to print out of a member variable. This member variable is called here A, and interesting about this member variable is it is of type A, which is our struct A here on top. And the important thing here to know is that even we call here our variable, we are starting here, right? I create here this variable, it jumps here in this constructor, and here this constructor is not executing the body here now. That's very important. What I mean with that is this body here is executed after all other variables or what you have here is finished. What I mean with that, if you have here, for example, int, let's call this int number, and then let's initialize a number here, number 45, for example. If you have something like that, this constructor body will be called at the end. And the reason for that is if we don't call this one at the end, then this one can't never be initialized, and that would bring us an error. Why would we make this an error? For example, if I have not created this variable, let's say I call this one, and this one calls this one, and this one would execute this one, and this one would execute now this one, and this one is not finished, right? If this one is not executed, then this one would make us an error. It would say A is not declared or defined or whatever. We have no access to it. And there is the rule that when you call a constructor, this constructor is calling all other, let's say all other member declaration will be called before it is executing its body, because when it's executing this body here, it means you are finishing this object here. You are declaring and defining your object with the end of this body here, which means all other things must be first yes, initialized, declared, or whatever, so that we have no problems when we want access to them. All right, I hope that makes a little bit sense. So what I tried here to say is just this one, this constructor body is called at the end after all is initialized. Keep this in mind, that's very important. So when you see something like this one, this one will be called before initialized before this body here all time. All right, I hope you understand this. If not, try to read this like all time in a good C++ book, because this one is just a little bit my explanation and it's not all time perfect, and you should read this a little bit more in this online books, which I said you should anyway have on the side while you are watching this video. So, and with that, you should understand what happens here at this struct here, because the other difference is here that this one is still first here, the implicit this implicit constructor is called, but the implicit constructor here will call first this one here. Like I said, this one must be called first, and this one is just a constructor of this A, which is here. And what happens is then this one is setting this, and later in my example, for example, I have now here this example, set up this example. What we expect here, when I create this variable, and with this setup, we expect that I get here an outprint which is 1, and I should make perhaps a new line as well, so that it's not causing problems. And so we expect here that the 1 is printed out, right? Let's see if it's true. And indeed, we have here the number 1, which is here printed out. And the reason why we can do this, like I said, this must be initialized before. And if this is initialized before, means this 1, which was here a default value, is passed here, passed in, it is in, and I access it here because it was already finished here at this point. If you understand this, very good. It's not too difficult, just not that you declare later anything other way around and it's not working and something like that. So with that, let's continue this section here at least. What do we have here? This one we skip. This is again with which we have not talked. And here, this one I think we have talked in our last video. This is the same thing here with this reference, and I explained to you, if you have something like this is new a little bit, because, well, I say new because it's in classes. You can declare it like this. Outside of a class you can't do this because you have to initialize it directly, but there is a rule. The rule is that you have to define it in your initializer. With other words, this one here, what you have here, will not work, and you can see FF is an error because this will not work, because you have to define this one. In my last video, I think we have talked about it, and so I think you know what this is, right? If you see a reference, it must be initialized in the constructor. And the only difference is you can now declare it like this one, because that we could not, because all time we had to declare it and initialize it at the same time. That's so the difference. So with that said, let's go here, and the other ones we can skip, I think, because they are not, because there is something what I want to talk before again. Here we are we are calling GG here again, and this is the constructor ourselves, and there is something which we have to learn before, I think, which is a delegate constructor, and then we can talk about the other examples here as well. Okay, with that said, we are a little bit finished, not full finished, and in the next video I think we will dive into this side and try to make this finish, which is we will go to this delegate constructor what I just mentioned, and it will be calling our constructor again, and we have to talk a little bit about this one. And yeah, with that said, I will stop here, and I hope you understand it so far all. If not, no worry, that's normal. That's why we try to learn it, repeat it, and use all time a good C++ book or online C++ book, what you find where all things are more defined, declared in detail. Like I said, this is all time a practical video, which means we can't do and dive into all details here. That's why you should all time read a book as well, where it's explained so that everybody understands it. With that said, if you have any questions, any complaints, or any tips and tricks, like all time, write it in the comments. And like all time, don't give up, have fun, and see you in the next. Bye.